Welcome to week 8, video 8 on rationals. First, we're going to simplify a rational expression, and you'll see I have two examples there. And remember, rationals are just fractions, except now we're looking at polynomials over polynomials as our fractions. For letter A, the first thing we're going to do is factor the numerator and the denominator. Then we're going to cancel out any like terms, and we get x minus 4 equals over x plus 7. That's our answer. In letter B, again, we factor the numerator, factor the denominator. We're going to cancel out any like factors, and we're left with z squared plus 4z plus 16 over 2z plus 5. Don't forget the domain. In order to see what the domain is, you must look at the denominators in the original polynomials in factored form. The denominator is limited by what would make the denominator 0. In this case, in letter A, our denominator is limited by -7 and 3, either of which would give you a 0 in the denominator and make it undefined. In letter B, the denominator is limited by -5/2 and 4. Again, that would make our denominator 0. Next, we're going to multiply rational equations. Rational expressions. Factor the numerator, factor the denominator, refactor if possible. In this case, we could refactor the x squared minus 6x minus 7 into x minus 7 and x plus 1. Now we're going to divide out common factors. The x plus 1's cancel, the x plus 4's cancel, and the 7's cancel, which leaves us with x minus 5 over x minus 7. These can really be fun. They can be like a puzzle. I hope you enjoy them. Next, we're going to divide rational expressions, and I have a pretty simple example first. Letter C. That's written as division. I'm going to change it to multiply by taking the reciprocal of the right-hand side, which is an application of fractions. I'm going to cancel my common factors of y, cancel my x into my x to the third power, and that leaves me x squared, which leaves me an answer of 6 over x squared. In letter D, I have a little bit more complex rational division problem. So I have a polynomial fraction divided by another polynomial fraction. I'm going to rewrite that as a division, break it down into two pieces, then rewrite it as multiplication by flipping the right-hand side, taking the reciprocal of it. Factor the numerators and the denominators. Cancel out my common factors. 2x goes into 2x squared x times. My x plus 2's cancel, and my x squared minus 2x plus 4 cancel. That leaves me with x minus 6 over x times the quantity of 2x minus 3. Don't forget your domain. The domain is very important, especially when finding asymptotes, and we're going to do that a little bit later on in this presentation. We're going to divide a rational expression, and I took this one from the book so you'd have an example of a little bit more complicated one. First, I'm going to find the LCD of each denominator in the numerator position and the denominator position. So that LCD is x squared y squared. I'm going to multiply the entire rational expression by x squared y squared over x squared y squared, which is really just 1. And the identity property allows me to multiply anything by 1 and get the identical same thing. The next step, I broke it down into baby steps. I'm taking the LCD times each term in the numerator and the denominator so that you can see how we cancel things out. The y goes into y squared y times. There's nothing else in the numerator that I can cancel. But in the denominator position, I can cancel out my y squareds. I can cancel out my x squareds. Now, my next step is to simplify the numerator by multiplying and getting rid of the parentheses. And I do the same thing in the denominator position. Now I take the GCF out of the numerator position, factor it out. I then take the denominator of x squared minus y squared, factor that, cancel out common factors, and I'm left with x squared y times the quantity of x plus y over the quantity of x minus y. Wasn't that fun? We haven't done a word problem yet in a video. I don't think I've done one yet for you. So we're going to look at the volume of this cubic box with a square bottom, and the volume is 4x cubed plus 4x squared plus x. That's a given. We're going to find that we know that the height is x. We're going to find the area of the bottom and the dimensions of the box when x equals 10. So first we have to look at the formula of the volume. The formula of the volume is length times width times height. If the height is x, in order to get the area of the bottom, which is length times width, we have to take the expression in x of the volume of the box, which is 4x cubed plus 4x plus 4x squared plus x, and divide by x. That gives me the area equals 4x squared plus 4x plus 1. That's the area of the bottom of the box. Now I'm going to actually find out what the area is when x equals 10. I plug 10 in for each x. That gives me 441 units squared. Make sure you put the units in there because you know how strict your instructor is about having those units. The last thing we need to do is find the dimensions of the box. To find the dimensions of the box, we need the length times the width times the height. We know that the height is x. To get the length and the width, we take the area of the box in terms of x, factor it into 2x plus 1 times 2x plus 1, and now we know the expression for each of those dimensions. Plug the 10 in, and we're going to get 21 by 21 by 10 units. Next, we're going to add and subtract rational expressions. Remember, when you were doing fractions, if the denominator was the same, all you needed to do was add the numerators. So that's what we did. X plus 5 over x squared plus 7x plus 10. Now I'm going to factor the denominator to see if I can cancel anything. And my x plus 5's cancel. I'm left with 1 because when my x plus 5's canceled, that left me with a 1 in the numerator position. So my answer is 1 over x plus 2. My next example, the denominator is different in each fraction, so I must find the LCD. In order to do that, I factor each denominator. My LCD is the combination of all three factors, x plus 3, x plus 3, and x minus 3. Now I must rewrite my numerators on each side and multiply by the piece of the LCD that I did not have. So next step, I distribute the 6 and get 6x minus 18, distribute the negative 5, remember I'm subtracting, and get negative 5x minus 15. Watch your signs. Combine the numerator terms, and I get x minus 33 over that LCD. There's nothing I can cancel. Don't forget, you should always check your domain. This will lead you to the asymptotes when we're graphing, and that's coming up in the last slide. The very next thing is rational equations. You're quite used to the technique in fractional equations to eliminate the fractions, so that's exactly what we're going to do. First, we're going to factor the denominator to find the LCDs. And the LCD is x plus 2 and x minus 2. I'm going to multiply both sides by that LCD to eliminate the fractions. On the right-hand side, my x minus 2's cancel, so I'm left with 1 times x plus 2. Then on the second piece, my x plus 2 cancels, so I'm left with 2 times the quantity of x minus 2. On the right-hand side, my x minus 2 cancels and my x plus 2 cancels, so I don't have to multiply the 2 by anything. Now, this is what I'm left with. I took 1 times x plus 2, that gave me x plus 2, 2 times x minus 2, and all of my denominators are now gone, and it's set equal to 2. Distribute the 2. Remember, I'm distributing a negative 2, so watch your signs. Combine my like terms, and I get negative x plus 6 equals 2, which gives me x equals 4, and that's my answer. My last slide, of course, is the graph, and this is your favorite, I'm sure. So I'm starting with the function f of x equals 1 over x, kind of the standard form for a rational expression. I set up a table, find some values, and this is what my graph looks like on my graph paper. I have arrows on my lines. I have points that I have plotted. Now I'm going to label the graph with the equation, label the axes, label the points. I have a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0. That's because of the limitations of the domain, and the vertical asymptote is found in another way. I'll tell you that in just a minute. I'm sure you want to know exactly how to find those asymptotes. First, to find the horizontal asymptote, I look at the degree of the numerator and the degree of the denominator. The degree of 1 is 0. The degree of x is 1. If the degree of the numerator is less than the degree of the denominator, then I have a horizontal asymptote at y equals 0. And that is this red dashed line. To find the vertical asymptote, it is really actually much easier. Vertical asymptotes are the vertical lines which correspond to the zeros of the denominator. So in this case, my domain is limited by x equaling 0, and that's exactly where my vertical asymptote is at x equals 0. That's all for week 8, video 8. Watch for the PS and have a great week.